So welcome to my channel. In this video we will discuss about the syllabus of an undergraduate course in physics, which is of 4-year honors and honors with research. This is the revised syllabus of Calcutta University under CCF method. It is not CBCS. Okay, so if we do 4-year honors course only, then up to 8 semester you have to read some topics, some core topics with some advanced topics like advanced quantum mechanics, advanced statistical mechanics, and advanced solid state physics. But if we want to do 4 years honors with research, then you have to do some research methodology. You have to read some research methodology. You have to know about some research methodology, and you have to do some research intensive, as well as you have to do some research project in the last semester in case of 4 years honors with research. Okay, so in this video we will basically discuss about the syllabus of these two, that is 4 years honors and 4 years honors with research. Okay, so in the first semester what are the syllabus? So in first semester the papers are basically one paper is DSCC 1, that is the basic physics. Okay, in semester 1. So identical content with physics, this minor and minor. Okay, fine. So total credits on theory basically 3. This is the 3 credit subject, that is the mathematical physics. So there are some topics in this basic physics, that is the SI system, SI system of units, some dimensional analysis, some plotting of graphs. Okay, and finding a maxima minima of a particular given function. Okay, this is the first point. Second one is basically study about the differential equation, integrating factor, solution of differential equation. This is the ordinary differential equation, ODE, and some physical problem, simple harmonic oscillation, like that. Okay, and third is vectors, basically all about vectors, that is dot product, cross product, scalar triple, scalar vector triple product. Okay, and Levy-Civita symbol, Einstein convention, summation convention. Okay, and there are some operators, scalar and vector fields, gradient, divergence, curl. Okay, so these are the some important statement and proof of divergence theorem, Stokes theorem. Okay, these are falls under the vector. Fourth is the curvilinear coordinate system. Here we discuss about the all coordinate system, that is in generally we have to study that is one is Cartesian coordinate system, cylindrical coordinate system, and polar and spherical coordinate system. Okay, plane polar, spherical, cylindrical, and polar coordinates. Okay, so in general there is a form of all operators in general form, that is falls under the curvilinear coordinate system. Okay, here we have to study all of these things. So these are the 4 topics, main 4 topics falls under the mathematical physics in semester 1. Okay, fine. And second subject is classical mechanics. This is also 3 credit subject. So in first point we have to review the Newton's law that is the classical mechanics, Newtonian mechanics, concept of frame, inertial frame, then Galilean transformation, then Newton's laws of motion, principle of conservation of linear momentum, okay, acceleration. These are the things, basic things, rotational motion. Second is the potential work energy theorem. These, okay, all of these. Some conservation of conservation of energy. In third point, that is the dynamics of a system in system of particles. Okay, so the problem of solving the equation of motion, some things is there, linear momentum, angular momentum is there. Okay, all of things, action reaction kind of forces, two body problem is there. And fourth, central force. Okay, so Newton's laws of motion, Kepler's law, Kepler's first, second, third law, conservation of angular momentum, Gauss law of gravitation here is there. Okay, some application is also there. Okay, finite flat sheet, uniform solid sphere of uniform density. Okay, so this is in there. And also another two topics is there. One is the scattering, two body collision and scattering is there, small part in classical mechanics, only for the semester 1. And point 6 is the mechanics of continuum, kinematics is kinematics of moving fluids is there, some compressible, incompressible, what are the compressible, discussing about compressible of and incompressible fluids, equation of continuity, streamline flow, turbulent flow is there. Okay, Pascal's law, Archimedes principle is Bernoulli's theorem is there. Okay, so basically in first semester for physics honors we have to study only two subject, core subject. One is mathematical physics, okay, and basics topics is there all in mathematical physics. Some basic topics like plotting of function, differentiability, how to check the differentiability, how to check the continuity of a function, and Taylor series expansion, something is there. ODE, ordinary vectors is there. In classical mechanics also basics is there. So what are the recommended books for these two topics? So according to me, for mathematical physics, H.K. Das is good book. Okay, H.K. Das. And also you can okay, so for ordinary differential equation and vectors you can follow H.K. Das. Okay, and for the fourth one, that is the curvilinear coordinates, you can follow the Spiegel book. Okay, that is here. The full name of this book is this one. Okay, this is for mechanics book. So okay, for mathematical physics the book is this one, the vector analysis and introduction to the tensor analysis. So this is the best book for the vector analysis, for vector part. But for ordinary differential equation and Stokes theorem, Green's theorem, like that, you can follow H.K. Das. Okay, so this is for, and also you can follow the mathematical method for physicist, Artkan. And basically this book is very advanced. So if you already covered H.K. Das and Spiegel, then you can go for mathematical methods for physicist. Okay, now for classical mechanics you can for classical mechanics, according to me, you can follow A.B. Gupta. Okay, So here reference AV Gupta is not there, but you can follow AV Gupta, and after that, after covering AV Gupta, also you can study this one. There is a classical mechanics and general properties of matter, SN Maiti and DP Rai Chaudhary. Okay, you can also follow this one. Fine. So this is for first semester core course, and there is another course, that is the introduction to the computer programming and plotting of graphs. So these are the syllabus according to this PDF. Introduction to graph plotting, there is a GNU plot. Okay, introduction to programming in Python version. Okay, these are the some things. So there is problems and application. There is only one book for whole Python things. You can follow this one, best books according to me. There is a scientific computing in Python, written by Abhijit Kargupta. Okay, so this is the best book. So